So there's one like number 2, okay? I did it to where it's not multiple choice because number 1 was neither, but that's not what they got. So I just took number 1 off there, and it's like number 2, okay? So number 1's not on there. It's just going to be short answer. And what you have to do is see if it's inverse or direct. Remember, if it's direct, it would be, you would divide them to see if you get the same thing. If it's inverse, you're going to, I know this is for the problem above it, but I'm just writing up here. Okay, so let's say, okay, what's 18 divided by 7? I'll just see if it's direct variation. I don't even know. So if I have 18 divided by 7, I get 2.57. 37 divided by 11, I do not get the same thing. So is it direct variation? No. Now let's try multiplying. What's 18 times 7? 126. Okay, this is going to be a whole lot more than that, right? If I did 37 times 11, it's 407. So is it inverse variation? No, so you would put neither. All right? So you divide them to see if it's direct. You multiply them to see if it's inverse. Y'all need to remember that. But I'll say it right before tomorrow. It'll be the first question.
Remember what?
How to figure out if it's direct or inverse. You divide them for direct. Divide direct. Multiply for inverse. Remember that. Divide direct. Okay. Then let's see what's next on there. There's one like number 3, and yes, it's a fraction, okay? But all you have to do on number 3, remember for inverse, you multiply the two things. So I'm going to multiply 5/3 times 7. So look, I'm just going to do 5/3 times 7. And I get 35 over 3. Now, you'll notice, you can already tell your answer, right? But let me write 35 over 3. And I'm going to do y and x because that's what I'm used to. On inverse variation, where does my x go? In the bottom, remember? So, which one kind of looks like that? I used y and x because that's what we're used to. They used c and d. So you can tell it's a though. A is the only one that has 35 over 3, if you forget. Huh? Yeah, this one's on there. Now, where did that second number come from? They told you to plug in 9. What's 3 times 9? 27. Okay? So all you do is you multiply that times that, and it was 35 over 3. That's the only first answer that has 35 over 3. Okay, is everybody good with this one?
Hold on.
The second answer? Yeah, the second answer they said plug in 9. What's 3 times 9? That's where their 27 came from.
Okay.
Alright? So that one is on there. Okay, then we have the drama club. This one's on there. This is your whole first page. So it's 2, 3, 4. Alright, on this one, and it's multiple choice, just like it. So it says, let me see. Sorry, I'm just looking at something. Okay, good. It's got the number of students, cost per student. So how if it's inverse variation, and doesn't it tell us? Well, it doesn't say that, but it is inverse variation. So you multiply 3 times 24, 6 times 12, 9 times 8, and 16 times 4.5. If you multiply all those, what do you keep getting? 72. So we're saying if I multiply n times c, it's 72. I know that's not how I write their equation normally, but that right here is saying that's where you get the 72. The second thing says, how much per person would it cost if there's 12 students? So the number of students is, I would plug in 12. How much is that going to cost? What would you do to solve? Divide by 12. And it would be 6. Okay? It's the same, it's worked the exact same way on the test. That's like the third or fourth time we've had that problem. I think it's just the third time. I'm kind of cold. Are y'all cold? I think maybe it's just drinking that water. Okay, let's keep moving along. Let's see. This one, it says graph. Okay, just a hint. Okay, this one is on there. I'll make sure. But it could be negative. What happens if it's negative? Instead of being in these two quadrants, it could be flipped. So just so you're prepared. Or it might not be. One of the tests may be negative, one may be positive. All it is, though, is it's a number over x. Okay, it might be 2 over x. Or it might be negative 2 over x. Okay, but you're just going to graph it. And I would go to y equals 9 divided by x, graph. And there it is. That's what it's going to look like. So I would press second table and then just pick some numbers. Okay, so that has -3, -3. -2, -4.5, and -1 and -9 would be, I'm just going to kind of guess where it would be. And it's going like this, something like that. Okay, yeah, something like that. Okay, everybody good with that? Actually, it's not perfect, but all right. Then my other one, over 1, up 9. I'll just put that right there. Over 2, up 4.5. I'm guessing this one's going to be 3, 3. Because it's usually symmetric, but I'll scroll down and make sure. And then I'll just go one more. 4 and 2.5. I'm in 4 and 2.25. Okay, and it's, anyway, like that. No asymptotes, nothing, it doesn't ask for it. The reason it doesn't ask is because it's the x and the y axis. So it doesn't want you to cover them up. But that's all you will do on that one. Everybody good with it? I don't know if it's I'll have to see what kind of number. I don't know. All right.
Can we have like a little note cards for the holes with the asymptotes?
Yes, you can. For the horizontal and the vertical asymptotes, y'all can. Or do y'all want me to just write it?
Please.
Just write it? Okay. I can write it on there. Because that should be the only thing that is needed, right? I think that's, as we go through, if we think of anything else, I'll see.
Inverse and direct.
Y'all need to know that. Remember, direct if you divide. Inverse,
Yeah, but then they're backwards.
you'll just have to remember that one. Y'all can handle that. It's only like, 1 or 2 questions on that. Y'all got that. Okay, is there one like this? There's not one like this on there. I wanted it to be, but I had to get rid of some. Do y'all still want the answer though? Let me see if do I even have the answers out? I don't have your answers. Oh, this is number 4. No, number 6 is C. Yeah, but number 6 is not on there, okay?
On both sides.
But it was C. Okay, 7 is on there, and it says sketch the asymptotes and graph. It's going to say that, so make sure you do that. So my asymptotes, you're going to go left 2 and where? Down 2. Left 2, down 2. So I kind of make a little point, and that's where I draw a vertical and a horizontal line. That's my left 2. That's my down 2. Okay, asymptotes, check. Now forget about the asymptotes. Just graph it just like you normally do, okay? That's all you have to do on the asymptotes. Just left 2, down 2. Your graph that they give you, it should look like, you should be able to tell it's similar. So I'm going to press y equals. 3 goes in the numerator, and then several things in the denominator. So what do you have to do? Put it in parentheses. X plus 2. And then minus 2. Is everybody okay with that? And now I will press graph. And you can tell it kind of matches where I shifted it. So let's just look at our table and pick some numbers. Okay? There's several numbers to pick from. Remember, you graph just like normal. Start at the origin. Okay? So if I'm graphing, let's do -5, -3. What's another one? -3, -5. And I might do the one in between them. -4, -3.5. So it looks like it'd be going like this. Everybody good with that? Okay, and it matched. It stayed in that little area. Now my other one, it says -1, 1, 0. What does that say? I can't tell if they're clear.
-0.5.
No, okay, thank you. -0.5, so that's right here. And then 1, -1. And it looks like it's going this way. There we go. It fits my little asymptotes, okay?
Okay, I have a question.
Yeah.
About the asymptote. So, the left 2 is the +2, but
It's-
you make it a negative.
yes.
Or if it's a negative, you make it a positive?
Yes.
Okay.
Yeah. So that would, if it had a -2, you would have gone right 2.
Yeah.
Yeah.
Okay, and then at the new, like the one in the fraction, is that your vertical or no?
Wait, what one?
The,
The
2, right there, in the fraction. Is that your vertical one or is that your horizontal?
that one is the vertical one. That one is left 2. So I would go over 2 and draw a line through it. Since you have shifted it, you can't draw a horizontal line through that because that means it hasn't shifted. So I just make an ordered pair of it and draw through the ordered pair. Chloe, that might make it easier. Do you want me to show you what I mean? Look at it as an ordered pair, not as asymptotes. Like,
So
Left-
-2 positive?
so left 2, down 2. So watch, I'm gonna go left 2 and down 2. Now let me draw my vertical and horizontal line through it. That's the way my mind does.
Does it work on all of them?
All of them. Wherever you move that ordered pair, now it's not your new starting point, that's just the asymptotes. Okay, that would help you know, there's my 2 asymptotes. They meet right there. Ah. Okay. But that, if that doesn't help, ignore it. All right, is everybody good with that one? Somewhat.
So,
Oh, you're okay.
You could write, I know you teach Bill about, can Sergeant James come in here and just speak to him about the ASVAB, like maybe 5 minutes? I'm so
Yeah,
sorry.
just when is he ready now?
Well, he's talking to the senior.
Yeah, just tell him to
5
come.
minutes.
Yeah,
Are you
whenever
sure?
he's
I'm
ready
so
to come
sorry.
here. No, it's fine.
Okay.
We only have a few problems to go through.
Okay, thank you.
can you
Tell me when you put that in your calculator so I can write it
I'll,
down.
it's a.
Yes. So, if the number on top, so you just put it by itself, 3 divided by. Now, Hannah Catherine, since there are several things in the denominator, they have to go in parentheses. So x plus 2 is all in the denominator, so you have to put it in parentheses. Okay? And then the minus 2, once you close those parentheses, the minus 2 will go out to the side. Okay? All right, let's keep going.
Who invented this? Like, what are we gonna use this?
We're going to use this today. Okay, number 8. Don't ask me that kind of stuff.
I like Japan.
Okay. This one's on there. So, and Lily, this kind of goes with your question. Since that's a positive 3, what are you going to put with the x?
Negative.
X minus 3, which is right here. And since that's a negative 6, you actually do put a minus 6. That's all you're doing. You make the x the opposite, the y stays the same.
Is that one there?
Yeah, that one's on there. I'm only doing the ones that are on there, especially because of the time. I wanted to make y'all an extra review, and he's coming in here now. So there's only 15 questions. What have we done, like 5?
You should have told me to get the next hour.
Yeah, that would be awesome.
So, oh.
Yeah, do it next hour.
I'm not in on that. It might be because he needs to leave. Okay, let's see what's next. This one is on there, number 9. So it wants to know same exact thing, Lily. I know I keep calling you out, sorry. But it's moved to the right 7. Does everybody see that? So that means minus 7. So it looks like it could be either of those. And then it has moved down 8, which remember the y stays, so it's -8. So that one is C. Okay? Same thing, like those 3 problems are basically the same thing. It's C, because you went to the right 7 and down 8. So the X is always backwards. The Y is exactly what you would pick it to be.
9's on there.
9 is on there, yeah. Okay, then we have number 10, and it's on there. And it just wants you to like list the points on number 10. Yep, I'm sure. I think he's...
I hate people like
Okay, aren't we on number 10? Yes. We did number 10? No. I think we were about to start number 10. Okay, you just find the 2 points, huh?
Hold on.
Yeah.
So 8, 9, and 10 are all on there?
Yes.
Okay. Let's see.
Okay, so number 10, all it wants is the 2 points of discontinuity. How do I know there's 2 points? That one and that one. What are they? They are -6 and -3. And you can put a comma between them. You could list them both like this. If you just put -6, -3, I would take it. It's all I'm looking for. What are they? It's just saying what 2 numbers can they not be? What can we not have on the graph? That's what discontinuity means. And like Lily said, it's just the opposite. When it's with the X, it's -6 and -3.
So that's,
So
those are holes in the graph?
no, they're just points of discontinuity. Those are actually asymptotes, but we're not even asking that yet. It just wants to know, this one's very basic. What 2 points can X not be? -6 and -3. That's where you would like have to pick up your pencil off the graph. You can't plot those points. Either it's an asymptote or a hole. Okay? That's all it's saying. Then on even on number 11, I'm guessing number 11. Is that the one?
Was number 10 on there?
So yeah, number 10 I have on there. I'm trying to see. Number 11 is not on there, so are y'all good with me skipping?
Yes.
Okay, number 12 is on there. So number 12, we just have to factor, and y'all, I think it should be all basic factoring, okay? So like number 12, the top looks good, so I'm going to leave my numerator. There we go. Now the denominator, the bottom, I know that's X and X, because I have to make X squared. Okay, and what times what is 54? So I would just come to this side, okay? Now, and you might have to list a bunch. So does that add up to 15? Yeah, so that's my 2. It's 6 and it's 9. All right. So answer the first part. What are the points of discontinuity? What was my -6 and -9? Is everybody okay with that? First of all, I'm listing the 2 things they can't be. That's why they're negative here. Are they all removable? Yes, they are. So it's D. Is everybody good with that one? Okay, let me see my next one while anybody needs to write that one down. What number is that? 12. Let's see, is 13 on there? 13 is on there. Okay. Anybody still writing 12? Yeah? Bryson, you still writing it? You sure? Okay. I'm just going to move this up and then I'll erase it. Okay. This one is on there. Okay. So the top, again, the numerator, X plus 2 is just fine. So now we factor the bottom. So I know it's X and X. And y'all, there's only one option. What times what is 2? Yep, 2 and 1. Does that add up to 3? Yes. So I've got 2 and I've got 1. So then it says, the first part, answer it. What are the points of discontinuity? 3 of these in a row. What are they? -2 and -1. So I would list them. Then it says, are they all removable? No. Only this one is. So the answer is no, but some of y'all asked me yesterday, what if you, kind of pay attention to that, what if you put removable for this one and wrote non-removable or not removable, I would take that. That's telling me the same thing, okay? So
Which one would you rather?
it's just no. So if you put no, then that's, but if for some reason, because when we did these on our, paper, and when I did these, this is how I work. So if you are stuck doing that, I'll take that. Yes.
So for the points of discontinuity, I would put 1 and 2.
You would note they are -2 and -1.
Okay.
It's always the opposite with the X. How is it?
One back.
They're dying to know. Okay. Anybody still writing 13? So y'all, all three of those last ones, what numbers were they? 10, was it 10, 12, and 13? They were all the opposite. We put the opposite number, okay? All right, so let's see what else is on there. That should have been that one. Okay, so number 14 is on there. Let me see if. And 15. 14 and 15 and I'm just trying to look ahead and see. 14, 15, and 16 are on there. Okay, so I don't think 17 is. All right, 14, 15, 16. This one you're going to have, let me fix that, it's blurry. You're going to have the little notes. Oh, Colton, did you have the notes for the vertical and horizontal asymptotes? Did you need
No.
them?
That's fine.
Do you need them?
I'm good.
Are you sure?
I think so.
Okay. Because I'm going to put that on the board. So do you need to make any changes real quick?
I'm good.
Okay. On this one, let's see. It says describe the vertical asymptotes or holes for the graph. So what about 1? So first of all, let's list our points. They would be 1 and 2. Okay, go ahead and list your points of discontinuity. So I get 1 from here and 2 from here. So 1 is a what? 1 is a hole because it cancels out. And so that makes 2 a what? An asymptote. So your asymptote is 2 and the hole is 1.
Wait, so what are you gonna write on the board tomorrow?
I'm gonna, not this one, it's not for vertical, it's for horizontal asymptote. Remember, if the numerator is greater, you do this. If the denominator degree is greater, if they're equal, that's what I'll have on the board. And there's only one of those.
Like the vertical ones too?
Well, you don't have, no, you wouldn't, there's no rules for that.
Well, like if it cancels out, it's a hole. If it doesn't, it's a asymptote.
Y'all gotta know that. But yeah, y'all got that. We did that for days. Y'all got that.
Yeah,
Y'all can remember that. If it cancels out, it's a hole. I think y'all got that. This one right here with the horizontal asymptote, if I'm honest, I can't even remember that rule.
that one's.
So, yeah, I mean, I know, no, they don't have the same degree. That's the only one I can remember. Okay, everybody's good with number 14? Yes? Okay. Then I told y'all 15 and 16. So they are. Yeah, I've got 2 vertical asymptote ones on there. Because those are pretty easy, I thought. So I left that one on there. Okay. And then the horizontal asymptote is the multiple choice. Number 15, it says describe any of the vertical asymptotes or holes. So first thing you have to do is factor the bottom. So it would be x and x. What times what is 10?
5,
And those add to 7. So 5 and 2. So what are the points of discontinuity? Every time we write the opposite, what are they?
2.
-5 and -2. And are they holes or asymptotes? They're both asymptotes. So, I mean, you could circle that, you could write it, whatever. They are both asymptotes.
Wait, can you do that again, please?
Yes, start from the beginning, or did you get the
I get
factor?
a 5 and a 2.
Okay, so you get this part? Now, that's in the denominator, so what can x not be? -5, -2. So I write those down. That's the first part of my answer. Okay? Then we're saying, are they asymptotes or holes? So do those cancel out?
They
No.
cancel out.
So they're asymptotes. So, which you could write it. I was just lazy and circled it.
So your answer would be -5, -2, and then asymptote.
And asymptotes, yeah. And if one was an asymptote and one was a hole, then you would need to say, which one was which.
So
Yeah.
there is no hole.
Nope, not on that one. Okay, but on 14 there was, okay? Can I erase? Yeah. All right. Number 16. This one is what's going to be on the board. The horizontal asymptotes. It says if the numerator degree is bigger, there is no horizontal asymptote. So by degree, that one has a 6 and that one has a 4. So the answer is no horizontal asymptote. So on this one, you look at the degree. Do you see your degrees are 6 and 4? What's above the X here?
Oh, okay.
Okay, and what's above the X here? That's what you're looking at. So if the numerator is bigger, then your answer is no, there is none. Okay? If the numerator was smaller, then it would be 0. That's just going to be your rule. Okay? That would be on the board. If they were the same, if they were both 6, then it would just be the numbers out front, like 1/6. Okay? But in this case, it was D, isn't that right? Yeah. Yes.
If, like number 17 is -6/2.
So it would
Did
be,
you simplify that or no?
yeah, it would be -3. What did they get? They got -3, but that one's not on there. It's probably going to be more like, I'm assuming, either 0 or none. But still, just they'll be on the board.
If the numerator is bigger, then it's none.
Yes.
And if the numerator is smaller,
Then it's 0. It would look like that. And if they were the same, it would be 1, because there's an understood 1 here, over 6, if they were the same. Okay? And this one's multiple choice, but that's all you're looking at. The 6 and the 4.
So if they were both 6, then it would be 1/6.
Mm-hmm. Yeah, those are your 3 options. Okay? All right. Let's see, 17's not on there. All right. So let's keep going to, I don't think 18's on there.
You said 19 wouldn't be on here. Because that one's terrible.
I think I might have to make one up. I've only got 2 left.
17, 18, 19 not on there.
Let's see. Yes, 17 is not, 18 is not. Okay, when I say there's one like 19, it is and it's not. Okay, I'm going to make one up that's more like it. Okay, let me see. Number 20, does this one have a hole? No.
I have a weird.
Let me make up 2 graphs, okay? To do. Are y'all good with that? That it'll be more like? Yes, no. Do y'all want the answers? Huh?
Can I erase these and just write your new problem?
Yeah. All right, I needed just a second. That is,
She's making up 2 new problems just like the ones that are gonna be on there.
Yeah.
I just need a second. I think this is gonna work. Hold on. Did I just... Let me see if this works. Oh, no, that one doesn't work.
Yo, where's that thing?
What is what?
That little arrow thing, that little thing.
Oh, that's just another part of the graph. I'm trying to see. Let me see how this one looks. That one looks so good. I've got to make up one like that. Hold on. Y'all, let me pause my video. Y'all, I just need just a minute. ignore this. Y'all, it's going to be so much like this one. Actually, let me rewrite that. It's going to be just like this one. All right. So I've got this over this. First thing I want us to do is, well, I guess we can graph it, but then what are we going to have to go back and check for? Well, so we might check for that first. Asymptotes and holes. And that's what's going to say on your paper. It's going to say asymptotes. This is not for points. This is for your help. Okay, like it wants to know what are your asymptotes, what are your holes, and then there's a graph. Okay, so let me put a graph. All right. And again, it is just like this problem. If I was to write one down and study it, this is what I would do. So the first thing is, let me just go ahead and factor the top and the bottom. Now, this right here is exactly what I'm going to enter in my calculator. But let's factor them. What does the top one factor to? Oh, I've got x and x. And what times what is negative 8? Negative 8 and a positive 1. Okay? That adds up to negative 7. Now, what's this one? And the denominator is the exact same on your test. Okay? It's x plus 1, x minus 1. Uh-huh.
Where did the one is the whole?
So, yeah, this is going to be the whole, which is at negative 1.
Where did the plus one or negative one?
Well, because that's a difference of perfect squares. You can always factor that. It's always x plus 1, x minus 1. So there's a whole, and it's at, what's your point of discontinuity? Negative 1. So I wrote my whole down. Then the asymptote, what's it going to be? A positive 1. So I'm just going to write those down for myself, okay? And then it wants me to graph. I'll go ahead and graph my asymptote. So I'm going to come over here to 1 and do a little dotted line. Okay? That's my asymptote. Is everybody good so far? Now, if I'm entering this in on the calculator, this is way easier to enter in than what I changed it to. So I'm going to do that. Now look, the whole top, and Hannah Catherine, this is what you were asking about a little while ago. Since there's several things in the top, that has to go in parentheses, and several things in the bottom, that has to go in parentheses. And then I'm just ready to press graph and get some points. Okay? There it is again. Okay, so can I press graph? Here's my graph. All right, this is exactly what your graph should look like on your test tomorrow. It's not one of those crazy ones. It took me forever to make one like that. Okay? Now I've got to do second table and plot some of the points. So let's see. I'll do that negative 6, 2. That one looks good. I'm going to graph them in red. So I'll go over from my origin, 1, 2, 3, 4, 5, 6, and up to. Let's see another one. What is that? 0, 8. That's like right here. And I may put one more. I may do like negative 4, negative 2.4. Something like that. There's just several of my points. Is everybody good with that?
Do you have to draw the horizontal asymptote?
Oh, it does probably want me to draw the horizontal asymptote. Where is the horizontal asymptote, y'all? You can look on your graph and tell, or since and it's going to be the same thing, they have the same degree. So it's at x equals 1. Okay? Now let me go. So I'll put my dotted line in a second. Let me go back to my table. So, for what? Because x squared over x squared, the number out front is 1. That goes back to your rule, okay? Now, I'm gonna pick some other numbers. Let's see, okay, let's see, 2, -6. Let me scroll down. Here we go. And I'm gonna go back to that hole in just a second. Just ignore that for just a second. 2, -6. So over 2, down 1, 2, 3, 4, 5, 6. I'll do, let's see, 3 and -2.5. And then maybe one more. I can't tell those numbers. Let me go a few more. There we go. 8, 0. Okay. There's my graph. So I've got a horizontal asymptote, a vertical asymptote, my graph, and what's the other thing? The hole. And if you'll notice, there's an extra error on your calculator. Why is there an error at -1? Because there's a hole at -1. So I would just go and make like a big circle, which you could erase it or whatever too. But I mean, I'm not even going to erase it. I'm just going to know, okay, at -1, go to your graph, and that's where the hole is.
So you just put actually.
What number is
I'm just wherever my graph is. It's probably not in the exact spot.
that?
Because I'm just
like higher.
So yeah, it is like my 3 points that I picked were this point, and this point. I guessed all the rest of those. I tried my best. So all I can do is go over -1 and wherever my graph is, put a hole. That's what I'll look for yours. Yours should be something similar shaped, okay? And I'm just gonna go over -1 and make sure you have a hole there, okay?
Can I have a graph stamp?
Uh-huh.
Are we doing another?
Yeah, I have one more if we have time.
That was 19.
That was 19. So we just have our last one. Here you go. You want to put it on there?
Oh, yes, ma'am.
Okay. The last one is multiple choice. It's so all you have to do is graph it and match, just like your number 20. But I think it's a little bit easier. It is going to look just like this right here. Your 19 and your 20 are just like these. Okay? So tomorrow on your test, when you do your number 19, oh, it's okay. It should look just like number 20 on your test. Meaning like it doesn't have 3 graphs, okay? It might have a hole in it and all that. So I'll make up one of these. How are we on time?
5
Barely
minutes.
making it. That's okay. All right. Are you done? Oh, not yet. All right. I will write this. Let me write one down. This is going to be our graph. Okay, this is going to be our graph, like number 20. So I don't know, like if I can make y'all an extra practice. I don't know today if I'll be able to put some, like 19 and 20, I might, okay? So on this one, all right, what you're going to do is, the hardest part is going to be typing this in your calculator, okay? So if I go to y equals, I have several things to type in. So you have to put 2 sets of parentheses up top. What goes in the first right now? X minus 2. Close them. Then another set. What goes next? X plus 3. Close them. Then I have to close the entire top. Okay? Everybody good with that? Then I put divided by, and how many sets of parentheses do I have down here? 2 again. I'm going to put X plus 3 and X minus 3. Close them twice. Okay? And then you graph it. Are we ready to graph?
1 second.
Oh, sorry. I'll go back. Y'all still typing?
Yes, ma'am.
Oh man, it went to the x plus 3 and then x minus 3 and double close your parentheses. Y'all, this one's multiple choice, so I'm not even going to draw it. I'm just going to point out where's the hole going to be at. -3. Can everybody see that? What cancels out? These do. So look real quick because we're running out of time. If this is my graph, on my multiple choice answer, that right there is what you're looking for. You're looking for the picture that matches that has a hole right there at -3. Okay, they're going to have 4 pictures for you to pick from. Does that kind of make sense? So that one's way easier than number 19.
Will you reset that?
Yes, so you'll graph this, and then you're going to have 4 pictures to pick from. So they're probably just going to be moved around. You're looking for the picture that has the same type of numbers graph, but that hole is at what number? 1, 2, -3. Because what cancels out? That x plus 3. Which remember is the opposite, Lily. It should be -3. Okay? I'll try to make, who all wants that extra? 4. 1, 2, 3, 4, 5. 5 extras. Okay. I will try to do that now in this class. Yes.
Do we know what it was on?